Welcome to Lesson 3, Reflections. This is our second type of transformation that we'll be looking at in this week. The first one you looked at was a translation. And just like a translation, when we reflect an object, we keep the same size and the same shape. But instead of sliding, the object gets flipped. But again, we keep the same size and the same shape. Our objectives are to reflect an object over both the x-axis and y-axis, as well as over the line y equals x. In order to better do this, we will be coming up with some rules that we can follow to help us when we are reflecting an object. In this first part, we're going to reflect the object over the x-axis and then write a rule. If we look at these two triangles, triangle ABC is on the top and triangle A prime, B prime, C prime is on the bottom. So we know this is our image. This is the reflection of triangle ABC. Remember that the image is notated with these primes. If you'll look here, point B is 4 units above the x-axis. If we count up 1, 2, 3, 4, then we know that when we reflect over this axis, which we can also call our line of symmetry, think of it like a mirror, then point B must also be 4 units below the x-axis. And we can count 1, 2, 3, 4 to make sure that it's the same distance on both sides. Let's find a rule. Let's see if we can see some patterns. So if we look at point A, let's start off with point A. Point A on our original image is -2, 1. Now if we are going to reflect this point here over the x-axis and come down here, notice that our x value didn't change. We still came out -2. But our y value does change. Instead of being 1 unit above the y-axis, now we're 1 unit below. So we end up with -1. So if we want to think about what happened with our reflected image here, our A prime, we kept the x value the same, but we changed the sign of our y value, so now it's -1. So we changed the sign of the y value. Let's look at the B coordinate. We started off with B at 2, 4, and if we follow what we said, we're going to keep the x coordinate the same, so we'll keep that as 2, but we'll change the sign of the y coordinate, so now we'll have a -4. And notice this is what we have down here. And so our final point, C, 4, 2, again, if we follow what we've set up for our rule, then our C prime should be 4, -2, and you'll notice that it is. So what can we do for a rule? If we reflect over the x-axis, then we can say that we are going to take the x-coordinate, keep it the same, and then we're going to take the opposite sign of our y-coordinate. So whatever our y-coordinate is, if we multiply that by a -1, that will change the sign. So it wouldn't matter if our original triangle was down below, because if we multiplied a -2 by a -1, we would get +2. So if we just always think of that as take the opposite sign, this is going to be our rule. So this is our rule for reflections over the x-axis. Write this down in your notes. So this is the rule for how to reflect over the x-axis. Keep the same x value, multiply the y value by a -1, or change the sign. Now let's look at how to reflect over the y-axis. So let's find our original triangle here. It looks like it's to the right because we have triangle ABC, and our image is to the left because this is A prime, B prime, C prime. Let's think about what we did here. If we start off with the A coordinate, which is at 2, 2, let's look at our x value. So we are here at 2, but we don't keep the same x value because we're not reflecting down. We're reflecting over the y-axis. So now, instead of being 2 units to the right of the y-axis, now we are 2 units to the left of the y-axis. So notice that now we have a -2 instead of a +2. But our y doesn't change. We're still the same distance above the x-axis over here on our original shape as we are here on our image. So the y stays the same. Let's see if that works for all the points. So we start off with b is 4, 4, and if we look at b prime, then our x value should change sign. So we should change that to -4, and our y value should stay the same. And that's what we have. And then our final point, c, we start off with 5, 1. If we take the image, well, our x value should change sign this time, and our y value should stay the same. So let's write a rule for this. In our rule, we would say then that we would take our x value and multiply it by a -1. So we'll take a -x, and our y value will stay the same. And again, it wouldn't matter if our original triangle was over here on the left side, because if we took a -5 times a -1, we would get +5, which is what we have here. So as long as we take our x value and multiply it by a -1, or change the sign, we should be able to get our reflected image. So try to associate the y-axis with a -x, and try to associate the x-axis with a -y. They're somewhat opposites to help you remember, but you can also put this in your notes, and you can refer back to it. Let's look at our final reflection. How do we reflect over the line y equals x? That's a little bit more tricky. But what I've done is I've created the line y equals x here on the graph. Remember that this line goes on forever in both directions. It's a line. So our intercept, our y-intercept is 0, 0. And if you'll notice, this is y equals x plus 0. That's why it's 0. Our slope is just 1, right? There's a 1 in front of the x, so it's 1 over 1. Up 1 over 1. Up 1 over 1. Here's our original image in purple up here on the top. We can tell because, again, it's triangle ABC. Our reflected image is down here. Look at how these compare. So if we think about that we wanted things the same distance from the x-axis on one side as the other side, same with the y-axis, it's the same principle here. Whatever distance we are from this line y equals x, it needs to be the same distance on both sides. But this is difficult to count because we're not counting along a straight line. We're counting along kind of a diagonal. So it is very difficult unless we have a ruler and we come at this y equals x line perpendicular. So for example, this C point right here, if I come here down to this line, I would need to come out at that same angle down to the C point here. And that's very difficult to do on your own. So it's going to be really important to have a rule to represent this information. So let's go ahead and think of what we can do here. Our point A started off as -4, 2. When we reflected it and we got A prime, our new point was 2, -4. When we started off with B as -3, -1, our reflected point, our B prime, comes to -1, -3. Are you starting to see a pattern? Think about what pattern, what rule this could be. If you think you have the rule, go ahead and write it down in your notebook, and then we'll examine it together. Okay, so hopefully the pattern that you're seeing here is that all we're not changing any signs. All we're doing is we are flipping x and y. We are changing their locations. So we're taking x and we're putting it in the y spot, and we're taking y and putting it in the x spot. So our rule would simply just be y in the x spot, x in the y spot. And that's all we have done in order to reflect this object. And that will really help us, especially if we had a shape that looked like this. Say it crossed over this. That's a very difficult shape to reflect, but if we know the coordinates of the vertices, all we have to do is flip them and then plot them, and we have our reflected shape, our image. Okay, as we wrap up, let's go ahead and give this a try. Let's take a shape that crosses over and try to reflect it. So the first thing we need to do is come up with our coordinates. Let's go ahead and write the coordinates of A, B, and C up here so that we have those. The coordinates of A are 1, 9. The coordinates of B are -5, 6. and the coordinates of C are -2, 3. Okay, keep in mind your rules. We want to reflect this over the x-axis. So how do we do that? Hopefully right now you're looking back in your notebook and you're seeing that all we have to do in order to reflect this is to change the sign of y. So we would have 1, -9. For b, we would have -5, -6. And for c, we would have -2, -3. All I did was change the sign of y. Now let's graph that and see how it looks. And here is the graph, our image. And remember that when we graph our image, we always want to make sure to label the corresponding vertices. So we would have C prime, B prime, and A prime. Now let's look at how we would reflect over the y-axis. If we go back to our notes, you will remember that in order to reflect over the y-axis, all we have to do is change the sign of the x value. So now our A prime would be -1, 9. Our B prime would now be +5, 6. And our C prime would be +2, 3. So I kept the y's the same, and I just changed the sign of the x values. Now let's graph that and see if this shape makes sense. And notice this is going to be much more difficult because our shape crosses over the y-axis, crosses over our line of symmetry. So our new shape, our image, should overlap our original shape. Okay, and here it is graphed. Here is our image, and you can see that in fact if we were to put a mirror on the y-axis here, this orange triangle, our original object, would reflect and look just like the green image that we have. But again, having the rule helped us to do this correctly. But notice that our original A point is 1 unit away from the y-axis, and our reflected image, the A prime, is also 1 unit away. So it still follows the same rules. Now let's do our very last one, the reflect over the line y = x. In order to do this so that we can see it better, I'm going to go ahead and erase what we have, and then I'm going to put in a dotted line y = x. Okay, so think about what our image might be if we reflected it. It's pretty hard to draw it, but if you'd like to draw it and just see how you do, go ahead and give it a try. Pause the video and see if you can give it a try. And then let's use the rule and see how close you were. Okay, so if we remember our rule, and if you look back in your notes, all we have to do, we don't change any signs, we just flip the points. So x becomes y and y becomes x. So all I'm doing is flipping my points for my A prime, for my B prime, and for my C prime. Now we can graph these points and see what we get. And here's what we have. And you can see that clearly if you put a mirror down this center line, y = x, that would be your reflected image. And this concludes our lesson today on reflections. So you should be able to take your rules, apply them in order to reflect any object over the x-axis, the y-axis, and the line y = x.